I'm going to be walking you through Block Qualified, which is a dApp I made which completely decentralizes credentials from getting them to verifying their authenticity. I'll explain why this is important, what the dApp actually does, and finally we'll see how it leverages zero-knowledge proofs to ensure fairness and privacy, so that cheating becomes mathematically unfeasible. But first, take a look with me here at this tweet by 6529. It's part of a thread where he reveals he's going to be participating on a fully on-chain university course. But there's one piece missing. How do we do exams on-chain? You can't just submit your answers inside a transaction because transactions are public and anyone will be able to see those answers. One could just copy them, cheat on the exam, and gain the same credentials as you. We will need to somehow hide exam answers while still being able to check if they are right. All of this inside of a public ledger. And that is exactly what Block Qualified does. We'll be going over how it does it later on, but first let's just see a quick demo of the project. So to create your own credential, you go here on the Create section, and first you will define your exam by giving it a title and a description, and then you can just fill in your different questions, right? So we have here sample question with a set of answers. You define the correct answer, and this text right here supports Markdown as well. And you go ahead and pin it to IPFS, and we're going to be keeping the content identifier once it is pinned to IPFS. So credentials are basically NFTs that are non-transferable. The metadata, which is this IPFS link, is going to be used as the token URI. And this number right here, we'll see it later on, it has to do with the zero-knowledge proof going on in the background. We could just define our own credential, give it a simple name, and then we could just mint our own NFT, which will live on the chain forever for anyone to solve and gain our credential. Very simple. But now, how do you privately solve a multiple choice test on chain? Well, there's a pretty good explanation here in the homepage, but the key here is that you do not actually send your solution, but rather a proof of your knowledge of it. So with every new test, like the one we just did, we define a new Merkle tree with the correct answers sitting at its leaves. Now this Merkle tree is going to have a root, which we're going to call the solution hash. So for every new test that gets defined, the solution hash is going to be part of the NFT that we just minted. When you solve a test, what you send is a proof. And in this proof, you show that you know an answer tree doesn't need to be the correct one, which has a certain root, which when hashed together with a salt, which is a random number that gets voided, gives us a solving hash. So that is the proof that you provide. The answers tree remains private so that no one can copy your answers. The salt remains public so that we can void it and it can only be used once. The smart contract is then going to check if, when hashing the salt that you provided with the solution hash it has stored, does it reach the solving hash which you gave as part of your proof. If it's true, then you solve the test and it will give you the credential NFT. Now let's see this in action. I have here a simple test I made earlier, which is called Understanding the Ethereum Virtual Machine. If I were to try and solve this, well, first of all, we're just going to give it an incorrect solution. So all the answers here are A. I invite you to try this test because it is quite tough. If I click here on Submit Solution, it's going to generate the proof in the browser, the way we just covered, removing all the friction from the user. And the questions here are very tricky. There's a link down in the description if you wish to try it. And it's going to try and send a transaction, but as we'll see, it is not going to let us because this transaction would have reverted as it is not the correct solution. Now here I have the actual correct answers for this test, and now if I click on Submit Solution, it will generate the proof again, and much the same way as we just described. Now the files necessary to generate these proofs are hosted on IPFS to ensure maximum decentralization. Now, this proof takes a little while to compute, so we're going to wait a couple seconds here. And there we go. It's going to let us send a transaction now. We will receive our MetaMask pop-up. And here we go. It's going to let us submit the transaction on MetaMask. I'll click here on confirm. And this is because these are the right answers. And once I send the transaction, with this, I just minted myself a credential NFT that links back to this test NFT, and in doing so proves that I have some EVM basic knowledge. How cool is that? So we covered why we need exams on chain to be able to fully decentralize credentials. We saw how Block Qualified does this by letting you create and solve tests which get pinned on IPFS. And we explained the zero knowledge tech behind it, making it all possible. Now you can find a link to the public repo in the description down below, and a link to this functioning web app if you wish to try it. And finally, if we update the page to the test I just solved, we can see here that the trophy counter increased by 1 because I just got my EVM basics credential. And that's it. Thank you all for watching. Have a great day.